Alright, welcome to day 4 of doing Leetcode 75. This is number of promises, which is 547. And so let's read the problem statement. There are n cities, some of them are connected, while some of them are not. If a city A is connected directly with a city B, and a city B is connected directly with a city C, then A is indirectly connected to city C. So a province is a group of directly or indirectly connected cities, and there are no other cities outside of the group. You're given an n by n matrix is connected, where is connected of I and j is equal to 1 if I is the ith city and the jth city are directly connected, and when it means that is 0, that means that they are not connected at all. So you have to return the total number of provinces. So for an example, we have, so each node corresponds to what edges is what nodes is connected to. So 1 is connected with itself always. 1 is connected to 2. It goes the same for 2. They're directly connected, and 3 is by itself. So that means that there's 2 provinces, since that's the number of connected components we can make. So the way that we have to solve this problem is by doing something called a depth first search. So we said here in the problem statement that A and C can be indirectly connected to each other because B is connected to C, but A is not connected to C. So what we have to do in this case is we have to go down the path of all of the connections that A has. So it goes into B first, so then B, since it's connected to C, then we go into C. And then we can say that, okay, we marked all of these like kind of like as seen. So these are all within one component. So we can all consider all of that as one singular component. We can move back up the tree and look elsewhere to see if that there's any direct connections or not. So let's go ahead and code this out. So for simplicity, we're just gonna take we're gonna call this n. We're going to keep a track of all of the indices we've seen. So like essentially we're going to have 3 seen right here, and we're going to, if we're able to kind of go down like the first index, go through all of the directly connected components, then we can kind of mark those all as like, okay, we've seen these already, so let's go to one where we haven't seen it yet. So we're going to iterate through the list of the is connected. So we're going to say that for I in range of n, we're going to say if I is not in scene, or if scene of I is false, we're going to increase the count. We should have a count to see the number of provinces, and we're going to run some sort of DFS function. That means we're going to keep going down this, like, we're going to keep going down this the directly connected components and see how many other like connected components there are, so that we can go on to the next element, and then we can go down that path as well to see how many connections we need to make, and then we can just return the number of times every time we were able to go through one whole group, essentially, right? So that's what this like for loop does initially here. So we're going to go through 1 and we're going to check through its connections. So we're going to see that, oh, there's 2 here. Let's go inside of 2 then, and then let's see like what it's connected to, and we're just going to build out, we're going to do a, like, we're going to go through the entire depth of these edge connections, and we're going to build out that this is one whole province. And then when we go on to the next like elements within this array, since it's not seen, we're just going to skip them until we find a whole new connected component that we can go through. So for the DFS function, we're going to go this is DFS on a node. We're going to say that, okay, once we apply DFS on it, we're going to mark this as true, that we have seen this node. Okay, and then we're going to iterate through all of like n again, and we're going to actually go through all of the nodes we're gonna go through all of the edges inside of that node, right? So we're gonna say that if is connected, like if it's equal to 1 essentially, of the node at any of these places, and we haven't seen it yet, then we're gonna run DFS on that, right? So what that means is that let's just check if this works. Yeah. So what this means, right? So let's go through like how the algorithm will run. So we have a scene list of 3, which are all false. That's the length of the list. So we're gonna go through this node first. So we're gonna say if not scene of 0, we haven't seen it. So we're gonna go inside of here. We're gonna increment the number of promises to be 1, and we're gonna run DFS inside of this node here. We're gonna set this node to be true so that we've seen this node already, and then we're gonna iterate through all of the edges inside of this node. We're gonna check, okay, this is this is 1, but so is a truthy value, but then we've already seen that node, so there's no reason for us to go inside of the 0th node again. So we'll go ahead and go to the next element, which is the second one, or which is like the first index. And we're going to say, okay, this is connected and it has not been seen yet. So we'll run DFS in this node now, okay? And then since we've already seen 1 and 2 inside of our scene list, well, after we run this one, it's going to set node 2 to be true. So afterwards, we can't run any more DFS, so we just go through these 2, and then we come back out, and then we run line number 18 on node 2, and we realize that it's already true, so we have to go to the third one, and this one is just connected by itself. So we're gonna increment the number of promises to be 2 now, and we're gonna do DFS on this node, and then we're gonna set that node to be true, so everything has been seen. So then when we iterate through the entire array, all of them are going to be shown as true. So it doesn't matter what the values are inside of here, since we need to have this second condition in order to go inside of DFS. And that should be the solution. Thanks for watching.